Hello, my dears. I hope that you're all doing well and in good health. Previously in science, we talked about so many things. We started with material changed, we finished material chains, and then we started with forces and motion. We differentiated between weight and mass. We also started with the forces, okay? So in the previous lesson, we explained what are the forces. Some facts about forces were also mentioned during the explanation. We also clarified force diagram and balanced and unbalanced forces. So this lesson is a new lesson of science. We will start with forces and energy, but first we need to make a review of the previous lesson. So please tell me or write down what are the forces that you've studied previously, and tell me the facts that you know about it. You can just write down the facts below, like in the comment section. Uh, we also know that forces work in pair, so could you tell me how they work, like in pair? What does it mean? Uh, and tell me also what's a balanced and unbalanced force or forces. Okay, so forces and energy. Let's see what do we mean by forces and energy. Actually, first thing that we need to concentrate on is why we need to use force, or why force is needed. If I tell you to move a car, you simply will tell me, you simply will tell me that car cannot be moved by me. If I say why, you say it's because that car is heavy. Actually, that's true, it's heavy, but there's something that makes that car heavy. It's because of its mass, either it's because of its weight or mass, like both of them, or there's something else. We know that we have gravity. Gravity pulls everything, or gravity tries to attract everything towards the earth. Okay, so in here we have something, a new notion, which is called by inertia. Inertia has a definition. The definition is the tendency of an object to stay at rest or preserve its state of motion, which means that thing, for instance, we have a car, you want to move it, but that car doesn't want to move. So what's the reason? It's because it has its own inertia. It doesn't want to move. It has tendency. It has to stay. It has, like, that car likes to stay at that very particular position. Okay, so with no motion. Okay, therefore the force or the thing that is stabilizing this car is called by inertia. Okay, it's the car's tendency to stay, the car's tendency not to move. Okay, so just as a reminder, we have push, pull, friction, magnetism, and gravity as the forces. We will be studying friction. We will be studying friction. We talked about gravity somehow. We also know what magnetism is and how it works. We studied that in the previous lessons. So push and pull were both explained in the previous lesson as well, and we're going to pay attention to it further during this lesson. So a force is needed to make objects move or to stop them moving. So if you look at these two pictures that you have in front of you, the very top one is of a boy trying to move that toy car. Okay, so he simply pulls the car and the car is moving. Okay, so a force is needed to make the toy car move, and it's the boy that uses that force. Okay, therefore the car is going to move. Previously we talked about the opposing forces. As you can see in the below picture, the car is going to what? To go towards the wall. Okay, so the wall is stopping the car. Therefore, a force is needed to stop the toy car from moving. Okay? The force of what? The force of the what? Of the wall. When we exert a force on an object to make it move, we give the object energy. That car in here doesn't have any energy. So in order to move, you need to use a force. Okay? So now the force that we use for the car to move, what we do, we give the car energy. The amount of energy transferred to an object to make it move is called work. So what do we call the energy that we give to the car? We call it as work. Okay, so there's a work done in here in order to make the car move. Okay, so then as you can see, there's a boy who's actually kicking the ball. The force from the boy's foot transfers energy to the ball. The ball moves and work is done. Why? Because he is transferring energy. He is giving energy to the ball. Okay? Therefore, we say that there's a work that has been done. The amount of work, like the work, how much work is done, actually depends on how far the force makes the object move. You're using the force to make an object move. For instance, if you have your iPad in your hand, if you have your phone in your hand, if you have your laptop in front of you, you simply pull the laptop and you're moving the laptop. If you are putting more force on the laptop will move more, will actually get more away from the it will be no longer in front of you. Okay, so it's moving away because you've done a much work on it. Okay, so therefore the amount of work done depends on how far the force makes the object move. The further the object moves, the more work is done as more energy is transferred. So it's about the energy. As long as you're using more energy, it means there is more work done. Okay, so the work depends on the energy. Therefore, we call the force applied to an object work. Okay, so the force that you're using or you're applying or you're performing to an object is called by work. When force is applied to an object, it results in the movement of the object. Okay, as you can see in the picture, there is a guy trying to move a box. Okay, so there is a force in here which is called by force of gravity. Okay, there also is a force that is of the person. Okay, so when he grabs the box, he moves. So that box is no longer at that place. Okay, or in that place. What he's doing, he's displacing the box. He moves the box to another position. Okay, so in here we say that the work is said to be done. So there is a work that has been done. By who? By the man. What he did, he moved the box, okay, to another place. We have different types of work. Okay, we have positive one and we have negative one. Okay, as you can see in this picture and read what's in front of you, man does positive work, lifting the box. So the man is doing or is trying to lift the box. In here, this type of work, he's working on the box, is called by a positive one. But if the man is lowering the box, that's negative one. Okay, therefore what we do, we're going to clarify it in the next slides. Gravity does a positive work when box is lowered. Why? Because we said that gravity is what? Gravity is actually trying to move all the objects toward the earth. Okay, so gravity does a negative work when box is raised. Why? Because there is a force on the box that moves the box and that actually lifts the box. Okay, therefore the job of gravity is no longer there. Because what? Because there's a force that's moving the box. A positive work follows when the force has a component parallel to the displacement, which means there must be displacement. There must be that thing moving from, or that object is moving from a place to another one, from a direction to another direction. Okay, so this work is positive because of what? Because that thing has been moved, that thing has been displaced. Okay, while the negative one is what? Negative work follows when the force has a component opposite or against the displacement. For instance, there's a what? There's a game that's called by rope pulling. Okay, so you're pulling a rope and your friends are pulling a rope as well. So you and your friend, we have two people. You actually have what? You actually have the rope in your hand, okay? And your friend has the rope in his hand or her hand as well, okay? So you both are pulling the what? The rope. What happens? There is an opposing force. There's an opposing work on the work that you are doing or you are performing, okay? Therefore it's negative. It makes you not to move that object. It makes you not to move the rope. So there is an opposing work on the what? On the displacement that you are trying to make. Okay, therefore it's a negative work. So the work is not actually done properly. Okay, therefore it's negative. We also have another type of work which we call as zero work. Let's see, we know about positive. Positive is actually a win. It's when you are doing the work properly, you're displacing something. But negative might be the lose. Okay, why? Because you cannot do it. Your friend is going to win. Okay, there's an opposing force, there's an opposing work on the displacement. You're not going to succeed. But the zero work is what? The work done is said to be zero work when force and displacement are perpendicular to each other, or when either force or displacement is zero, which means you are trying to actually to push a wall. Let's say it's a clear example. What happens? That wall doesn't move. Okay, therefore you haven't done anything. Okay, you are not succeeded, you're not successful in that case. Okay, therefore there is a zero work done. Okay, nothing is done because the wall is not moving. Okay, as you can see in these examples provided, in the left picture, what happens? No matter how hard or how long you have pushed, if the crate does not move, then you have done no work on the crate. So we have a crate in the picture in the left side of the screen, as you can see. What happens? That man tries to actually move the crate, but he cannot do it. Therefore, no work is done. Also, we have another case which we call as constant velocity. So in the case of constant velocity, it's when an object is carried at constant velocity. So what's velocity? It is an object is the rate of change of its position, which means the object doesn't change position. Okay, it's what? It's in the hand or that man is carrying the object, but the position has not changed. Okay, so the example at right, if the box is being carried at constant velocity, then no net force is necessary to keep it in motion. The force exerted by the person is an upward force equal to the weight of the box, and that force is perpendicular to the motion. If there is no motion in the direction of the force, then no work is done by that force, which means that box is carried, okay, and it's not moving to different directions. Okay, there's no motion for the what? For the box. We call it as constant velocity. Okay, therefore the position is not changing. Okay, so we call this as what? As zero work as well, because there is no motion, there's no change in here. Okay, therefore that man has done nothing. In here we're going to see how force affects an object. If there's a force on an object but the object doesn't move, no work is done. For instance, it's a clarification of the zero work. For instance, this guy over there just went to gym. It's the first day. He's trying to carry about maybe this side, the right side is about 15 and the left side is about 15, which equals to, or which is equivalent to 30 kilograms. So that man tries, or that guy tries to carry this in his first day of gym, but he cannot do that. So that's what? That's no work done. Even he uses force, but still there's no movement. Therefore, this is a zero work. If no force is applied to a ball, it cannot move and no work is done. So in here you see this ball and you see the goal over there. Actually there must be a player to put force or to apply force to the ball in order to give the energy and move the ball. If the ball is not moving, if there is no force, if there is no energy transferred, there is nothing done. Okay, therefore we call this as what? As zero work. Okay, so now we know that what's a positive work, we know that what's a work itself, we know about the forces, and we know about energy. Then what happens to an object if a force is applied to it? I want you to answer these questions in the comment section. What happens to an object if a force is applied to it? Second one, mention the types of work and give example for each one. So how many types of work did we have? Mention all of them and give example for each one of them. What do we call the force applied to an object? We have a force applied to an object. What do you call that force? So these are the examples and this is the clarification regarding the topic of what? Of force and energy. I will share more questions and assignments for you after watching the video. Thank you very much for watching and have a very nice day. Good luck.